Well, friends, today we are going to solve some problems with respect to electric potential and electric field. So, electric potential, as you know, suppose you have a charge q, then at a distance of r, we have electric potential as k q upon r. This you already know, where k is 1 by 4 pi epsilon 0. This is also called Coulomb's constant. Now, suppose you have a ring with radius r, and you are asked to find out what will be the potential at O, which is x distance from this ring perpendicular to the plane of the ring. This ring is horizontal and this is on the y-axis. So, suppose this lambda is charge per unit length. Then naturally your total charge will be lambda into 2 pi r. Here, suppose if we take this point, then what will be this will be, suppose this is R, then we will be having electric potential as K lambda 2 pi R upon what is R is basically root x square plus r square. So this is in case of a ring. This is basically a ring. But suppose it is a disk. And you are asked to find the potential here. With this analogy, we can find out the potential of disk also. Suppose you take a small thing here. Whose width is dr, and this is at a distance r. And here your sigma is charge per unit area. So naturally your lambda charge per unit length will be sigma into dr. And this is the distance. Suppose this is the distance r dash. So here we can write K in place of lambda, it is sigma into dr. This is 2 pi r, because here this r is this. Your distance is naturally x square plus r square it is basically due to a portion of ring, but we want to find out the potential due to disk. So we have to integrate this from 0 to r. Suppose this is and this will nothing but this will be dv. V will be 0 to r k sigma dr 2 pi r upon x square plus r square, and this will be nothing but sigma upon k sigma 2 pi, and this will become r upon root x square plus r square. When you will integrate and put the values, and this will give you x square plus r square minus x. So in this case you are this value. So with this analogy we can find out the potential on a point which is perpendicular to this plane at a distance of x in case of ring as well as in case of disk. These concepts you must be clear. Another question I have come across regarding the electric potential. Suppose you have a drop, water drop. Its radius is r and suppose it has charge q. Then naturally potential on the surface will be k q upon r. Now suppose you have n drops like this. And they are all joined together and become a bigger drop. Then what will be the electric potential in this case? So suppose the total charge Q is here capital Q, then capital Q will be nothing but NQ and they are combining to form a one drop. So we are assuming that there should not be any volume change. So the volume of this, suppose it is V will be nothing but 4 by 3 pi r cube will be nothing but n times volume of one drop that means R is n times 1 by 3 into R. So here again, now we know R, we know Q, we can find out what will be the electric potential. That will be nothing but K NQ upon R is here this and 1 by 3 R or K and 2 by 3 Q upon R. Here K is nothing but 1 by 4 pi 70 coulombs so this is how we can solve this problem. Now we will see one more problem which appeared in this JEE Advanced question paper quite back. I came across. If the problem is like this, this is your x-axis, this is your y-axis. So this is origin. You have charges placed at 1, 2, then 4, then of course 8, 16 like this. You have Q, 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 Q. Like that, this goes on up to infinity. Now we have to find out what will be the potential at origin. Potential at origin will be nothing but K Q fine. Here what will become 1 plus 1 by 2 plus this is what is this? This is nothing but GP. That is geometrical progression. Geometrical progression, we know that the sum of this will be A upon 1 minus R. So, what is A? Is the first term. 1 minus, what is R? It is the ratio of this divided by this divided by this divided by this. It is nothing but 1 by 2. Or it will become 1 minus 1 upon 2, 2K R. Sorry, 2KQ. Now in this question, suppose if we change a little bit, alternate charges are minus. Then what will happen? Let us see. Okay. Now we can, whatever plus are coming, let us this is minus, then this K Q upon 2 plus Q upon 8 plus, you can write this. This will be minus Q upon 2, minus we have taken outside. So all these factors which are minus, they will be summed here, and the positive factors, they are summed here. So in this we can write K Q minus Q upon 2. If we Q upon 2 here we take outside commonly, then here it will become 1, here it will become 1 by 4, he like that. So that means q upon q minus q upon 2, we take outside, then this will become 1 plus 1 by 4 plus 1 by 16. This is another GP. Correct? Now, K, Q minus Q, this is Q upon 2, and here A upon 1 by, this is A1 divided by 1 minus, here basically R is 1 by 4. This will be nothing but, this will be K Q by 2 into, it will be 3 by 4, 4 will go up and 3 will be like this, then it will become 2KQ upon 3. Correct? Simple, with the simple mathematics, we can solve these kind of problems. And this is a real-time JEE Advanced problem. Of course, it's a very old problem. It was asked very old in 70s, but it's a very good problem. So now we will do some more problems. Now we will solve some problems pertaining to electric field. Actually, electric field, you already know that if charge Q is there at a distance R, it will have electric field in this direction. This is the direction of field, and its value will be correct. Now, if the same way, we have to find out the electric field due to a ring at point O, which is x distance above this ring, perpendicular to the plane of the ring. If ring has radius r, and suppose we take this point, then with reference to this point will have electric field in this direction, and it will have these two components, E sin theta and E cos theta, where theta is this. This component E sin theta, this will cancel out because ring has the uniformly distributed charge, that is lambda, charge per unit that means the total charge on the ring is nothing but 2 pi r into lambda. So we are interested in basically this component, that is E cos theta, and electric field at point O will be K Q cos theta upon x square plus r, because this is the distance basically we have to consider, and this distance is nothing but x square plus r square, because it is r square. R square is nothing but x square plus r square. Q is nothing but lambda 2 pi r, and cos theta is nothing but x upon x square root x square plus r square. That means this is k 2 pi r lambda upon into x upon x square plus r square to power 3 by 2. So this is the electric field at point O due to the ring. Now the same way, suppose it is a disk and we are asked to find out electric field due to a disk at point O. So, if you take a ring here basically we are given sigma, that is charge per unit area. Naturally, for this ring, it will be sigma dr, where dr is nothing but thickness of the ring and it is at a r distance and radius is r. So in this case also, this will be k, here 2 pi, here r is given r, because this r is nothing, for this ring this r is there. Lambda is nothing but sigma dr, correct? And your x upon x square plus this will be r square 3 by 2. Correct. Now basically it is the electric field due to the ring. So total electric field due to the disk will be k 2 pi sigma x upon, or you can write this, it is 0 to r dr upon x square plus r square correct. Now when you will solve this, this will come as k sigma 2 pi one minus x upon root x square plus r square. So this will give you the electric field due to a disk on a point O, which is x meter above this disk. So now we will take some more problems. Well, in the previous problem we have seen this is the ring. In the previous problem, we have seen at point O, this is the radius R. At point O, we have electric field that is K 2 pi R lambda x upon x square plus r square correct? We can write this as, here basically K is 1 by 4 pi epsilon 0, that is coulombs constant, and Q is nothing but 2 pi r lambda. So we can write it as K Q x upon x square plus r square 3 by 2. Suppose a charge Q minus is placed here. What will happen? Let us analyze. If charge Q minus is placed here, naturally F is equal to, it will experience a force, and that will be K Q upon x square plus r square 3 by 2. And this force, naturally, here we have taken E cos theta like this, but since this is minus and this is plus, this Q is plus, so it will have, force will be in this direction. And one more assumption, suppose x is very and very less than r, then we can write it as K Q x upon r cube. Correct? Since the force is in the downward direction, we can write this thing as a minus K cube. Now just analyze this. When this charge is here, it is experiencing a force like in the downward direction, it will come here, and then again due to inertia it will go down. But once it goes down, then it will have charge. Due to its minus charge, it will experience a force like this. That means this charge will come down, then it will go up like this. It will be doing a oscillation. Simple harmonic motion means oscillation. Oscillatory motion it will experience. Correct? It's a very good problem. This, if this is minus charge, then it will go down. It will go for, once it goes further down, it will experience a force in the upward direction, and this we can write it as nothing, which is our, where K dash is nothing but this. And what is this? In the spring case, we have seen motion is directed towards the origin. So this is a simple harmonic motion, and this will oscillate, and we can find out the frequency. Angular frequency will be nothing but, correct? So you can be asked angular frequency or frequency, anything. But if you suppose this mass of the charge is given, then all these questions can be asked in this problem. So you have to see a lot of mechanics can be generated due to this electrostatics forces. So now we will solve some more problems like this. These are very good problems. You must understand. Now, as we have seen in case of electric potential, suppose you are given this 1, 2, 4, 8, these charges are placed like this, and you have to find out the electric field at the origin. So in this case also nothing but K Q upon 1 square plus Q upon 2 square plus Q upon 4 square plus Q upon 8 square, like that. It is up to infinity, because these charges are going up to infinity, or definite amount of charges can be given. Any type of question can be asked. So, but solution is simple. That is KQ, and this is 1 by 1 plus 1 by 4 plus 1 by 16 plus 1 by 64. This is again a GP, and its solution is nothing but A upon 1 minus R, or we can Q. This will be A is nothing but 1 minus, this is 1 by 4. So here AK, this will be 4 Q upon 3. K is nothing but 1 by 4 pi. Please don't forget. Like that, we can, these alternate charges can be minus also. So in that case, this A0 will be nothing but K Q 1 by 1 square plus 1 by 4 square, like that, minus K Q upon, or 2 square plus Q 8 square, like that. So this can be K Q minus Q upon 2 square, we can add 2 square, then it will become 1 by 1 square plus 1 by 4 square, like that. Correct? This will be nothing but K3 Q upon 4, and here we can write it as 1 upon 1 minus 1 by 4 square, that is 1 by 16. This will be K3Q upon 4, and here 15, 16, so 16 upon 15, correct? So this will be 4, this will be 5, or 4K Q upon 5. So this is how we can solve this kind of problems. Another problems, simply this type of also has been, suppose a pendulum is given, it has mass m, naturally this will have mg, and suppose this is in the electric field E, and it has charge Q, then this will be F is equal to EQ, and you are asked to find out the T. And naturally, suppose this is theta, so T cos theta will be nothing but mg, and T sin theta will be nothing but EQ. Correct? So in this problem you can be asked angle also. If electric field is given, this mass is given. You can be asked tension also. What will be the tension in the string? So by just manipulating the mechanics within these electrostatic forces, you can be asked so many questions, but you must be clear in the concept. Your mechanics must be strong. There is no doubt about it. If you are going to do the engineering, your mechanics has to be strong. If your mechanics is strong, then this physics paper will be very easy for you. So thanks for now and wait for my next video. Please do subscribe my YouTube channel, and we are going to bring you very good questions. No nonsense question will be there. The questions will be there which will definitely help you in the exam. And this is my idea. That's why this is how I choose the questions basically. I'm not choosing the questions which are very easy and just formula based. In the questions you will find some kind of trick always, and this is my idea. You must understand. This is how you can sharpen your concepts. So thank you for now. Goodbye.